This is the 32 and 32 mic capacitor, main smoothing cap, 350 volts working. This is leaky. It draws over 2 milliamps per section. When I last checked it on a little power supply with a meter in, it was drawing between 5 and 6 milliamps, so certainly out of spec, no longer good enough. So the idea is it's going to get replaced by two modern 32 mic 350 volt caps, and the idea is to remove the end, remove the insides of it, fit those two on the inside, connect the two prongs up to there and the earth up to this ring with the studs that actually holds it in place. I am not going to video myself struggling to get this open, because one, it could take a long time, and two, I only have about 10 minutes on the video. So catch you in a little while. The ring has been teased out, all the metal eased back. The next step will be to remove that. Now this is not the easiest, it's sealed in. There'll generally be a bit of tie behind that, locking it in place and sealing the whole canister as well as the rubberized top. So again, a bit of care taken, certainly not going to move like that, so some bit of gentle heat will probably be put around the sides to try and soften things up and ease the top out. Okay, as mentioned, a bit of gentle heat on the outside of the can. This one was only sealed by wax, and it allowed the wax to soften to allow me to draw the thing out of the top. So this is the double capacitor, and if I snip these legs off, the wires here are in aluminium, so I can't solder onto those things. Yes, I'm pretty sure they are, so I shall myself, there you go, a little bit of leeway. I shall check, but certainly feel aluminium. And that was the earth connection, which would have been trapped by this against a metal can. So that is going to get replaced by this, and these terminals, because I can't solder to those, I shall drill little holes next to the studs, then bring those up and wrap them around the base of these tags, so I can solder them on, and also bring out this through a small hole, so I can actually take it, not necessarily just to that, but solder it onto the metal ring. That is solderable. It is a soft iron, so I can solder onto that. Okay, the next step, it will be assembled. Okay, the terminals are soldered up, the metal ring has been put back on top of this, the earth soldered to the ring. The final thing now will be to bit of hot glue inside here just to stop the caps from moving. Then that will be put back in there, pressed in, and then the part I've actually peeled back, put back over to seal it all again. Not that I need a seal on this, because obviously those caps will be sealed, but it at least allows me to put it back on the radio as if it was the original. In one of my other videos I mentioned I was just going to replace all the caps, and I'm going to show you why I tend to do this nowadays. I don't fault find on these things. These are 0.05 microfarad, at 250 volts DC working. If I put on a DVM on resistance into megs. Now a DVM typically, or this one, only puts in half a volt across the caps. So 35 megs slowly climbing. $20, $30, $35, going up 40 odd megs. For 0.05, it should have been there by now, but 60 megs an open circuit. I'll do a third one. $10 megs and climbing, slowly climbing. But as I say, for 0.05 they should have been charged up by now. So you might look at them and think, yeah, not so bad. This is the one, a definite waxy. Again climbing, 16, 18, 20 megs, etc. And the last one I'm going to test and show you was this one, which is a 0.05 microfarad, which was actually across the mains. And this one, 0.8 of an ohm, so definitely short even on the DVM, so that's a no-go. Okay, the next thing I'm going to do is bring in my insulation tester, which will put 250 volts on it. So 2 seconds. And this is a Victor VC60 insulation tester, and I can set it to 250, 500 or 1000 volts, and that will apply them voltages to these pins, to the clips for testing. So all these are 250 volt working, so I'll set it onto 250 volts, and this will give me a reading in megahertz, megohms of what the resistance is when it's got a voltage on it. So this is one of them, 0.05, press to test, and dropping now 400k or 0.4 of a megohm. So big difference between testing it with a DVM at half a volt and actually testing it with a working voltage. So turn it off, try another one, turn it on, 200k, 0.2 of a megohm. Try it on the last one. Oh, turn it off so I don't give myself a quick shock. $900k, 0.9 of a meg. I can go through the waxy. $400k. Let's go through them all. $200k. And the last of the 0.05s. I think this is the one that would have been to the grid of the final output valve from the anode of the detector. 800k. Capacitors are one of those sort of devices that has a definite life, and as all these things typically with valves are well, this Eddystone is 1966-67, so it's already over 50 years. So the caps nowadays, I will tend just to replace the caps as a matter of course. I won't even spend time looking at them, but that just proves a little point as to why I do it.